Hello, good afternoon, good morning, wherever you are in the world. Welcome to Codebase Alpha. It's a special unplanned stream today. So we're doing episode 35 and we're going to continue looking at our Synthesizer project. The reason why I wanted to stream on an unscheduled day was that I actually received my very first pull request from an external person. So very kindly, Fuel Snable has submitted a pull request to the Synthesizer project, and I thought we could have a look at that on stream. Let's go and have a look at what's been sent over. So let's just hop into the code for a second. Okay, so I just want to quickly kind of recap of what we actually did on the last stream, which is only yesterday. We started to build this synthesizer and we got to a point where we actually got a monophonic keyboard, so we can do just over an octave of sounds. We've got various waveforms we can produce. There's a simple sine wave, which is a bit boring. We've got another sine wave here with lots of harmonics in it, which is a bit richer. We've got a square wave, which is very much like a traditional kind of synthesizer sound, very buzzy. And we've also got a sawtooth wave here. And we're going to eventually build it so that our little WPF GUI will be able to control the type of wave we get and switch types. And we'll try and enrich the kind of sounds that we can produce through varying the waveform. So we built this synth wave provider class, and this is all based upon N-Audio, which is a fantastic audio package for Windows and .NET, created by Mark Keith. And I wanted to kind of explore that a bit after I used it in the AlphaBot. That's where I kind of decided that we'd kind of build a synthesizer. It's really kind of the idea of another streamer called Javid X9, who also built a synthesizer in C++, though not using this library. But that was the kind of the inspiration. So I stumbled my way through building a WPF application, the very first one I've ever done. So this is what we built. We built a little form with a volume slider on it and an on and off button. And here's the XAML that went with it, and it was interesting to write, but I'm no expert. But when we were kind of started to wire this up, you can see we've wired the slider here to our volume property, and the label here, which is with this percentage volume, to a volume label, and we've got a couple of commands. Then Fuel Snable, who's one of our regular viewers, he chimed in and said you could create your view model, or part of your view model, which is this, using T4 templates. And that's always something that's always very interesting to me. So he actually said, which is a PR, to actually convert our project to using a T4 template to create part of this main window view model, and to take care of this wiring up all the properties that we've bound in our form. So let's pop over to GitHub and have a look at the pull requests. There's two pull requests at the moment. The only actual pull request with the change in is the one that Fuel Snable has submitted, which is this one here. And then this second one is by all contributors bot. So that's just going to basically add a contributor. So add Fuel Snable as a contributor. So let's go and have a look at this pull request. Okay, so it's a suggestion to use T4 to generate the view model, and I think that's a pretty interesting thing to want to do. So, and as it's our very first ever contributed pull request, I did want to kind of deal with it quite quickly, and also to stream kind of what this is all about. And I really like this idea. It's going to make looking after the view model a lot easier for me, and it'll all be generated. So let's go and have a look at what's changed. So we have 5 changed files. Okay, let's have a look. So the first one here is actually the view model which gets generated by the T4 template. So we can kind of have a look at that, but we'll skip over it for now and just come down here. So here's the actual T4 template that we're going to be using. So there's quite a bit of code down here. Basically, what this is going to do is it's going to for each through each of these properties and commands and actually create the controls, the code within our view model to handle them. So this is basically the bit that we will change. We'll change this section here, add any more controls, any more commands that we want into this portion, and the T4 template, when we build, will create a new partial class, which will be our main window view model, and there it will implement the iNotify property changed interface, and it will actually write all the code for us. Okay, so that's basically the idea. There's a few changes here. These changes here, when we view the file itself, is going to be our new main window view model, which we're going to put our own code in. The non-generated code is going to go in here. So this is the format of that code. As you can see, it's not that different from what we've got already. They've taken all the kind of properties that are in the other partial class, the file, and now we just have things like this constructed. So we can set the initial values in these constructed properties here. Okay. So that's the heart of that file. The only other change is where are we going up here? The other change is to our project file. So if we scroll down further, our user command changes slightly. Our user commands.cs file changes slightly, and our project file basically has this generation step in here. So it's going to build from the template. It's going to build our view model partial class for us. Fuel Stable, welcome to the stream. Good to see you. You like to call the first part of the model describing what to generate. So, okay, that's this bit here. So this is the model. Where are we? Here, the model. Yes. So this is the section here. Describing what to rest of the view is transforming the model into code. Yes. In order to inject the custom behavior, use partial methods. Yeah, so that's what these methods down here are going to do. So Fuel Stable says partial methods are a bit like static virtual methods. Added support for can execute in the command. Cool. So I think this is a really worthwhile thing to add. And it gives us a little more added interest to our basic WPF implementation, because the WPF is not the main focus. If we can kind of auto generate some of those features, that'd be great. So yeah, I think what we're going to do is we're going to approve this code, and we're going to merge it in. So thanks very much for the contribution, and we'll submit that review, and we're going to merge this in. So let's keep our fingers crossed, shall we? Let's confirm the merge. Okay, there we are. We're done. Okay. In terms of pull requests, there's also another pull request here, which is auto-generated by allcontributors.bot. And this one here is basically going to update our documentation. Okay, all it's going to do is update our README. So let's do that. Let's merge that in. Okay, so if we go back to our main project now, our README should have our contributors section that's been added, and we've got Morton's logo here, and his contribution was code and ideas, planning and feedback. So I really do appreciate that contribution. So let's go and grab this updated code and pull it down into our project. So we want to sync this with our GitHub, and then we'll do a build. Okay, let's build that. I've just spilt some of my drink. It's a bit alarming. Oh well, never mind. We're okay. Not going to my keyboard, I think. Okay. So, Fuel said it worked on my machine. Well, that's the classic comment of a developer, isn't it? It works on my machine. Okay. So let's have a look at what the changes look like in the actual code here. So we've got our T4 template, and we don't get any kind of syntax highlighting. So I think what we'll do is we'll open up code, VS Code, to have a look at that. Let's bring VS Code. I'll just open the file off screen because it might be a bit confusing otherwise. And I want to go to here. And then Synthesizer, source, and a TT file. Then we need, looks like we need a plugin. Template toolkit, T4 support, syntax highlighting, we'll have that. Okay, there we go. So if we bring this across, we've got the syntax highlighting now for our T4 template. Okay, so you can see here's the section that Morten calls the model, and this is where we're going to add any new properties and any new commands, and the rest of the code is what's going to actually create our class. So here's the class definition. It's a partial class, and then we've got these between these tags here are actually the embedded C# which is going to execute and run all this and populate the tags here. Okay, well let's give it a run. Let's just take that off, take that down. Let's give it a run and see what happens. Do we still have a synthesizer? Yep. Cody Beard, welcome. Good to see you. Yes, I got that plugin, Pure Stable, and it's really good. So let's see if we still got a synthesizer. We do, so everything still works, which is always a bonus. Okay, so that's our first PR pulled into the project. So how long did that take? That took 15 minutes. So we better do some more coding. We're not going to do a long stream today, but I did want to get that piece of code actually in, so that we can actually build from there. So if I kind of moved on without actually merging in that pull request, it would mean that FuelSnake would have to go back and change it, and then it's a lot of backwards and forwards. And we might as well get that change in as soon as we can. The buttons are disabled now, so let's run that. So you've added some functionality. So our off button, yeah, so off button is disabled until we put on button. So that was the can execute, which I didn't bother wiring up last time. So that's great. So when I switch on, then the off button is enabled and on buttons are disabled. So that's a nice added feature. Thank you very much for that, FuelSnake. That's brilliant. Okay. So what we can do. Okay, so what I initially thought is currently we are kind of passing the volume into our synth wave provider class, and then we're using that. We're multiplying the wave, all of the samples for our waveform by the volume, and it strikes me that we ought to start using the signal chain idea that comes with N-Audio. So the idea of a single signal chain is we can start to plug various audio effects together. It's a bit like having guitar, an array of effects pedals So your guitar is the input, so you go through a tuner, you might go through a delay, you might go through something, I don't know, a blues pedal, you might go through something which puts a wah-wah on it, and then eventually it goes into an amplifier and then into the speakers. And that's what N-Audio allows us to do. We have this interface called iSample Provider, and this is basically providing us with 32-bit floating point audio samples. So they're just a number basically between 1 and -1, which is the kind of position of the wave at that point, a point in time. We're creating a wave file here, which is basically a floating point file. So it's a buffer of floats rather than a buffer of bytes. And we're going to be reading from this buffer. We have a wave table in which we generate a single cycle of whichever wave we're working on, so either a saw wave or a square wave as we've got here, or a sine wave. And then we simply have a read method here, which when the audio player which we're using actually requests samples, it says I want count samples, and we give it count samples. And we kind of change the frequency based upon a frequency value. So, and that's the frequency value here, but the volume gets passed in as well, and I'm not sure really we need to do that. I think we should control the volume from within our view model, because this is where we're actually creating our player. So our players here, it's a class in N-Audio called a wave out event. So once again, we're using the WAV file format to pass our digital audio into this player. And this player actually takes, it doesn't take 32-bit floating point samples, it takes 16-bit or short integer samples. So we need to convert them. We've got a class here which N-Audio provides, which is the sample to wave provider, and we pass our oscillator into that. Now our oscillator is an instance of our synth wave provider class. So this converts the floating point samples into integer samples, and then the player can play it. Okay, so here you can see we've got our newly constructed partial class. So some of the other kind of stuff that we were doing with the properties are now off in a different in the other partial class, the generated version of this class, which is over here. This is the generated file, and we don't touch this because it's generated. As you can see, all the properties that we've defined in the XAML, which were the volume label, and the two commands are there. Okay, so we're not going to worry too much about that file. We're going to work in this file. Okay, so currently, when we change the volume, we're actually expecting there to be an instance of oscillator available to us to change the volume. And what I'm thinking is that there's actually a better way of doing that. When we construct our class, where's the constructor for the class? Here, constructed, I guess. Is that the constructor for your Snowball where I can add stuff? Let's have a look at our generated view model. Yep, that's okay. Where do we create our oscillator? So where's the constructor for this? Where I build my sample, my oscillator, or instantiate oscillator. So I've provided a new width provider there. Okay. Can I just have another constructor? Construction event rather than construction done. Yeah. Constructed is an event that is run after construction is done. So can I add a constructor? Is that what I need to know, really? Because what I want to do is to create a volume control. Constructed is a good place. Okay, let's give it a go. So in here we'll create a volume control. So what's the best way we do this? And we need a volume. We need a volume property, don't we? So we'll have a private read-only volume sample provider, which is a type which comes from NAudio. And basically what this type enables us to do is to actually just control the volume. That's our volume control. Okay. Here we'll say that let's just put the underscore in. I do like to have my underscore. Oh, I've just noticed something. There's a spelling mistake there. Let's correct that. Volume underscore volume control. That's going to be a new volume sample provider. And I think we can just pass in the volume. We just need to pass in our oscillator into there. There's our oscillator, and we can set an initial volume. Like that. So what's it? Alright, so we're not in a constructor. Okay. Let's see what happens when we do that. So this is a float, is it? Okay. So volume is currently a double, but we'll just what's the best way of doing that? We'll just set it to an initial value for now. Right. So then, rather than passing our oscillator directly into our wave out, our player here, we'll pass the volume control in. Okay, and because it's also an I sample provider, you need to forward to the default constructor. Explain to me if you're stable, so I can get used to this T4 constructed thing. Okay, and then we no longer need to have. I don't believe this is required at all. I don't think we need to do that anymore. If we go over to our wave provider here, we can set the volume. We don't need a volume. We don't need a volume at all. So we can lose some stuff out of here, and that's just going to be multiplied by 1 itself. So it should be okay. Okay, I'm using a constructed event, so I'm fine. Okay, well let's see how if this works as I'd like it to work. It should do, I think. So let's run it up. Switch on. So we haven't got volume control anymore. That's fine. We expected that because I set it to a fixed value. So That's the best way to do that then. So we want volume to equal volume. So 0.25F to start with, and then when we were adjusting the volume, which was here, then we can say, rather than oscillator, we can say underscore vol control dot volume is going to be that. So let's give that a go. Oops, what have we got here? Okay, my volume control is not instantiated. That's absolutely fine. We can fix that easily enough. And that is here. So that's going to be a new volume sample provider. Once a source, which is going to be oscillator. Is not there? Is that not available to us at the moment? Oops. Yeah, it should be. Cannot reference the non-static field or method property in the main window. I need that in the constructed event. Yeah. And what we'll do, is just do this. We'll just say that. Where's my volume control? If volume control not equal to null, then we'll do that. And then it should be caught. Okay, let's give it a go. Switch it on. So our volume control's working now. That's good. That's basically removed some code from our wave provider, which is we want this to be kind of small and sleek as possible, and moved our volume control into the place where it belongs, which is going to be as part of the signal chain. So what we've done, we've plugged our oscillator, which is our guitar basically, into a volume control, which is your amplifier, and then that has gone out to some speakers, which is our player. We're using a signal chain. So if yours number says initialize volume control before changing the volume, because your change volume is executed before you initialize for the first time. Yes. Is Matt, thank you very much for the follow. Let's give you some Electric Alf hype for the follow. Thank you very much, really appreciated. So we're now only 5 away from our 200 follower goal. So I'm really grateful for that follow. And this is a wonderful WebGL shader that FuelSnowball has built for the stream. So thank you very much. Okay. So I think we can probably, at this stage, we've started building a signal chain. I think we should probably next be able to control what octave our keyboard plays at. Because currently it's playing an octave starting at A2, which is quite low. And what we we may want to do is to change octaves so we can play at higher octaves. A2 is probably the lowest we want to go. It's quite a low sound, but we might want to play up. So should we do some XAML? Okay. So what is the best way of doing this? I think we should have a series of radio buttons up here where we can select which octave we want. So we want another row, I think. Now this is row 1, and our buttons are currently, where's that? Our stat panel's in row 2. So let's move that row down to row, I don't know, row 4, shall we? That's where our stat panel is now. So we should be able to put in something into row 2 underneath the volume. Let's try that. So what's that going to be? Is that going to be a stat panel as well? It might well be, I suppose. Let's give that a go. I don't really know. Let's go to stat panel. We don't need a name for it. It's going to be horizontal, and that should be enough for us. No, we'll put some more things in there. We need it to be in grid row. Row 2, perhaps. Yeah, row 2. Grid column 0. Grid column 0. Column span. Grid column span across all 4. And we had a margin. We seem to be having a margin of all the 5, so we'll do that. 5, 5, 5, 5. Until we know better. Okay, and then inside there we want some radio buttons. We want a label first, don't we? So let's grab a label. There's a label. I think we should better stick that inside our stat panel, and this be octave. Like that. And then we want a radio button. This is going to be radio button of name A2. That's going to be the name that it's going to be known by. And then we want, I don't know, we'll give it a margin again. Same old margin. 5555. And then we'll say it's got needs a group name, so it becomes a radio button group. A group name of octave. We'll make sure we'll have is checked true for A2, so that'll be the default. And then when we check it, we want to call an event, and that's going to be, I don't know what's going to call it. Let's set octave. Set octave event. That's one button there, so it's we need a label for that, don't we? Is that a name? That's got a name. Oh, it just needs to have, actually, looks like what it needs is actually to have the name in there. So that's A2. Let's copy this button times. We'll get rid of the is checked from these two, and we're going to have A3, A4, A3, A4. Okay, well that's good enough for me. I'm not a WPF programmer by any stretch of the imagination. I'm certainly not a front end developer. But let's kind of stretch ourselves and do a bit of simple GUI work, shall we? So there's our Octave Selector. Could do with that moving down. Wonder if you can vertical align the buttons. Let's have a look. Vertical align. Bottom. Is that gonna center? Yeah, that's better. Let's add that to each of our options. This is when you start messing around, isn't it, and start fiddling. So this slider's also up, so we could put a one of those on the slider as well, I suspect. Yeah, there we go. Yeah, this is where you start fiddling with bits and bytes, isn't it? Vertical alignment, yeah, thanks for your snowball. Yeah, so this is where you can get carried away with fiddling with your graphical user interface layout, but you might as well do it. Okay, so that's that. So we got a selector there. So we can close that down. Now over in our main window class here, we need to set up our the thing that's going to call this event, isn't it? So let's have a private. I don't think it needs to return anything, so that's going to be void. And we call it set octave. Set octave, is that what we call it? Yeah, I think we call it set octave. If not, we'll change it to set octave. And that's going to have it's going to have an object. This is going to be a normal kind of event, and I think it's what kind of event args is it? Rooted event args? Is that right? Let's try rooted event args. I'm not quite sure if that's the correct one, but we'll soon find out. And then we want to say we want to get something. We want to get the whatever the control was that initiated this event, raised this event. So Octave Selector is going to be equal to it's the sender has a radio button. So only a radio button can actually raise this event, so that should be a safe cast. So now we can say if our view model's not null, then we can put a switch in. So RB, no, it's Octave Selector, wasn't it? Octave Select dot name. So we'll get the name of the button that was pressed. So what I'm going to use is some code rush there to generate that. So Ancient Coder, welcome to the stream. Good to see you. So we're in the middle of adding a few features to our synthesizer. So adding an Octave selector, so we can change the range of our keyboard a bit. So that name should be a string. So it should be A2. Then we can say in the view model, do we have access to base frequency? We do. That should equal 110.0 F. Oh, it's a double D then. Is it M? It's read only. Okay, fair enough. We can change that. So our base frequency, we need to have a getter and a setter on there. Because it's no longer a fixed value, but we can default it to 110.0. Okay. So Ancient Coder, you need the VOD. Unfortunately, missed the last stream. Yeah, so it's actually up on YouTube as well. So episode 34, we start the project, and you can see me stumble through creating some XAML, which is quite amusing. But we do actually get the synthesizer to play some music. Well, to play a scale at the end in different waveforms. So it was a successful stream. And what this pop-up stream was really about, the PR that Fuel Snable sent in, which was to use T4, quite surprisingly, to use T4 templates to generate the view model, and we put that in there, and it's working beautifully. So that was a really great PR. So we do thank Fuel Snable for that. Okay, so we've got a base frequency there. Back in our main Windows XAML, we can now just copy these cases, and we can have A3 and A4. So A3 will be twice the frequency of A2, so 220 Hertz, and A4 will be 4 times the frequency of A2, so that's 440 Hertz. So we should now be able to change that. So Fuel Snable says you get even more benefits from generating dependency properties with T4 in case you want to make your own controls. Yeah, and we may want to have some nice controls. I did think we could have some that look more like audio equipment rather than the slider we got at the moment. Make it vertical, have a vertical slider with a kind of a nice rendered knob on there. But I'm not really sure how to do that kind of stuff. But maybe, yeah, who knows? It probably won't be in the immediate future when we get that far, but it could happen if I get all kind of into graphical user interfaces. Let's run up our synth and see what it does. Okay, so we'll switch it on. We're on A2, so this should be A2. Everyone hear that okay? So that's A2, and then we go to A3. A3 and A4 should be concert pitch. It's very high. So this is a square wave we're hearing. So this is the scale of C at the octave A4. A3. And A2. Wonderful. So we've got some octave control. What we have got at the moment as well is a monophonic keyboard, so we can't play 2 keys at the same time. If we actually run it up, start it up, let's go to A3 in the middle there. If I press the C key, which will be the note C, and at the same time I press V, I just get D. So I get C and then D. I don't get C and D played at the same time. What's the purpose of the project, Ancient Coder? It's really just to investigate the N-Audio library. It's N-Audio library is a .NET standard library by Mark Heath for .NET audio control. So it's a complete digital audio library. So we can go and have a look at that. Let's switch off. It's over here in GitHub, and it does an awful lot. So it has different types of APIs for playback, reading different audio files, converting between various forms of uncompressed audio, resampling as well. So in case you want to resample an audio file which doesn't play on a sound card, you can encode your own audio in various we're using various codecs, and then what we're interested in here is this mix and manipulate audio streams using 32-bit floating point samples. So it's got a full mixing engine. We can build signal chains. This is what I was interested in doing. And so the first thing that I thought we could try and build with it is this synth. So if you type !project, you get some information about what we're doing. So we're using .NET Core 3 and WPF. I've not used either of those things before. And I'm still learning a lot about digital audio processing. So I'm doing some courses from Pluralsight about all of this, and it's taking a while to sink in because an awful lot of it. The N-Audio library is pretty extensive, but it's quite interesting to play around with audio in this way. And I thought that we can use a couple of streams in creating a basic synthesizer, really, as like a demo of what you can do. Okie coke. So let's think what we could do next. Okay. So my plan for making a polyphonic keyboard was to go a bit kind of old school with how synths certainly used to work, and that is they have an oscillator per key. It's a bit like a church organ, which has, for each key, it has some pipes. So each key has its own pipe, really, and you've got various stops you can pull out to add pipes to that key. So yes, Ancient Code, I think it's a reasonably interesting, if probably not a very long-lived project. But I do want to kind of explore with some of the visualizations that you can get with this as well. So there is a fast Fourier transform sample provider, and we can get our hands on some pre-built graphics for a spectrum analyzer. So it might be interesting to kind of jazz up our user interface. So we've got quite a few controls on there. We can try create some instruments and some different voices, so that we can. So rather than just a raw saw wave, we can try and create a church organ sound. We can try and create, I don't know. We don't think we'll do a piano because we might try and do a piano, but it doesn't have that kind of. With a piano, it doesn't have that quality of when you keep the key pressed, the sound continues. But we'll see what we can do. I don't know how far we can take this, really, to be perfectly frank with you. It was just an idea to start playing around with N-Audio, and it seemed like I don't know. It seemed a bit interesting to have your computer generating sounds from your keyboard. A bit kind of different from the projects we've done in the past with APIs and things. So it was just a bit of a departure. Okay, so what's the best way of doing this? I think what we need to do is we need to have an array of oscillators. So let's think about that. Okay. So let's just write some code and see what happens. Let's have a private synthwave provider array, and we'll call that oscillators, and that can be a new synthwave provider array, and there's 16 keys, so we'll make that 16. Okay, we won't need this line after we finish, but okay. So what we want to do is we want to create the oscillator on demand. Okay. Let's go and have a look over in N-Audio and see what we can see in there. So, N-Audio, there is a mixer. I don't think we want a sample provider mixer. Where can we find a sample provider mixer? Not in here, is it? Wave. Sample providers. Mixing sample provider. I think that's what we want. Allow inputs to be added and removed. That's exactly what we want. So we want to be able to add any number of oscillators to this mixer, and it will mix them together and give us our blended sound. So this looks like it can take 1024 different inputs, which is well for us. We've only got 16 inputs at any one time. We need to give it a wave format. That's the constructor. We need a wave format, which is going to be our. It's going to be this one. It's going to be this floating point, 32-bit floating point wave format, which is what our samples are in. Or we could just add a list of sources, but that's not what we want. We want to add them dynamically. And we get, okay, what's this? Read fully. And set to true, the read method always returns a number of samples requested if there's no input. So we want this because we want our mixer to be always on. This, it says it's going to generate a never-ending sample provider, so don't write to a file. Yeah. So we want that read fully to be set to true. That's going to produce silence when there's no key pressed, which is what we want. What else have we got? So we got add mixer input. Okay. So we can add a wave provider or add a sample provider, and that's the one we're going to want to do. And there's an event handler that gets raised when a mixer input's been removed. And it's got a read method. So this is the thing about these sample providers is they're basically all got the same interface. They all implement iSample provider, which means they have a wave format property, and they have a read method. And it's this read method here which is basically going to do the mixing for us. It's going to take all the different sources and mix them together, and then we'll get one output of digital audio samples, which will pass to our volume control, which is the next effect essentially in our signal chain, and then that gets passed to our audio player. Okay, so we want a mixer. Let's go and have a look. Let's go and create one of those. So we've got sample, volume sample provider there, so that's a private. This is going to be mixing sample provider. That's going to be a mixer. Okay. So we need to create a mixer here. So this is going to be a new mixing sample provider, and it needs either a wave format or a list of sources. So we need to give it a wave format. So we'll give it one, and we'll define for wave format. Now this is basically the same thing we've got over here. This wave format here, wave format dot create IEEE floating point wave format. So because it's got to have the same wave format as we had as our samples going in. You can't have it have different kind of sample rate or whatever. We're going to hard code this at the moment, so it's going to be CD quality. 44.1 kilohertz, but it's going to be mono, single channel, because our synthesizer is currently mono. Maybe I'll do some to make it stereo. There's other effects that we can plug in to change our samples to be stereo, and then maybe we can have some effects where we can pan between speakers, which might be interesting. Maybe some kind of slider we can use to kind of slide between left and right. Okay, so we've got a mixer, and we want to actually pass the mixer into the volume control. So currently that's going to mean we haven't got any oscillators going anywhere. Okay, so we no longer need that. Okay, let's comment that for a second. Okay. So we now need to look at our key pressed, a key down and our key up. So okay. So before we go any further, what we're going to do. I think what my plan for polyphony is we're going to, depending on what key you press, you're going to create an instance of the synth wave provider which knows its own frequency. So let's go over here. So we want a base frequency. So public, was it a double? Yeah, double base frequency. Get set. In fact, yeah, get set, and we can default that to 110 Hertz. So we go default in there, and then the frequency of our oscillator is going to be the frequency that we calculated before over here. So where is the calculation for frequency? It's over here. So it's this calculation here, the base frequency times that. So we need to bring across our 12 root of 2. I noticed you changed to an exact calculation there, Fuel Snow. Well, thank you for that. So we can get rid of that, bring that over here as a private, and then we can say that we can take that. In our frequency, we can fat arrow that, can't we? It's going to be that, and we need the key val. This is going to be the note that we're playing. So we're going to need a note property. So we want an integer property, and that's going to be note, and we'll default that to being the note A. Okay, so we no longer need to set the frequency there. Okay. So we don't need that anymore. And we don't need that anymore. And in fact, our frequency change, we can probably now comment out the whole of that and see what happens. Right. This is a bit thinking on the hoof at the moment. Okay. So what my kind of idea to do is whenever you press a key, if there's no if that cut key has not been pressed already, we haven't already created an oscillator for it, we're going to create one. Okay, so I'm going to say and oscillators key value is null. So if it's null, then we want to create an oscillator in that slot. So we can say then oscillators key value is going to equal a new synth wave provider. And that's going to be we'll pass that in. If notes, we need to say what note it is. We need to pass key value into it like that. So let's go over here. Where's our constructor? And this is going to be integer note, and we can say that note equals note. In fact, so that would really mean this doesn't need to be a property. It can be a private read only, I believe. It can be underscore note. Like that. And that should default to 0 anyway. Let's move it into the right place. There's publics. We'll move it to there. And that's going to be underscore note. And that's going to be underscore note. And that can default to 0 at that point. Okay. So now we've passed that in, and then we want the base frequency because that's our variable, our Octave Selector. Okay. And then what we want to do, once we've created a new oscillator, we want to do mixer dot add mixer endpoint, and it's going to be oscillators key value. Now you may think it's a bit weird us creating these oscillators on the fly every time we press the key, but I've got a cunning plan really, because part of the next step for this synthesizer is to be able to kind of create envelopes, sound envelopes over your notes. At the moment, when you press the key, the note comes on full volume, and when you release the key, it drops immediately to 0 volume, to no note being played. But that's not how musical instruments work. At least not kind of analog musical instruments. They have a different sound envelope. When you pluck an acoustic guitar key string, you get a very quick rising volume, and then the note sustains for a while and gradually decays away, drops away as the note as the string stops oscillating or slows down oscillating. And the same with the piano key. You strike the key, it immediately sounds, but then there's, especially if you press the sustain pedal, it will last for a bit longer. So we want to kind of be able to do that. And so I think we're going to need to be able to create individual oscillators and have them created on the fly, so that we can have that shaping of the sound in the future. But that'll be next stream to have that, I think. Let's see if we can just get polyphony working. So, okay. So when we release the key, we just want to remove the oscillator. Oscillators key val. So that's a null. Okay, well, let's give it a go. I mean, what's the worst thing can happen? It can just sound awful or not work at all. So what we're hoping for here is to have a polyphonic keyboard, so that we can play a chord. Let's go for, we'll stick it an A, keep it an A2, then we'll change. So let's play note C, and then we'll play note of A. Okay, it's not working at all at the moment, so we've not done anything. Okay, let's go and have a look what we've done wrong. Created our mixer. Okay, what's going on over here? Base frequency, passed in note. So let's just pop a breakpoint in here, run it up and see what happens. On, press A. So note was 0, which we expect. We've got a wave format. Our base frequency is that. Our frequency is 110. So that seems to have created a we're going to create a wavetable, okay. Continue with that. Okay. Let me get rid of that. Okay, so it looks like we're setting up our note okay. Let's go down to here. Put a breakpoint here. Press note of A again. Oh, I need to stop it, I think. It's up again. Switch on. Play A. So that's a 0. Key values 0. Oscillators null, so we should drop into here. Create a new synthwave provider. So we've got one. Add it to the mixer. Our mixer now has one input. Is it the volume? Is it 0 volume? Is that the problem? No, the volume is being controlled afterwards. Should be full volume. So why don't we get any sound? So that was X. That should be a value of. So now we've got an oscillator in there. Oh, that. I pressed X then, so we should. Oh, it's interesting. That synthesizer is still there. We'll put one in there. Step in again. So now our oscillator should have one in the X key, which is correct. That's the note of B. Continue. rid of that. So that was me releasing that key. The key was 2 I released. Key value is correct. Oscillators. So it's removed that one. But we're still not hearing any sound, which is interesting. As they say, that's weird. So why can't we hear anything? What have I changed? This has got data in it. I'm pretty sure. Let's put a breakpoint in here, and so we're not reading anything, are we? Okay. I think we wired things up slightly wrong. So it must be over here where we've got a problem. Oh, I know why. Remember we talked about that producing silence. We needed it to run forever. Basically our mixer shut down immediately because it was silent. So we need to run always produce samples. Okay, I think that should be the solution. Because what was happening, because no key was pressed when the mixer started up, it immediately produced no output and then went away. Link Slumps, welcome to the stream. Good to see you. So we're trying to get our keyboard to be polyphonic now, and let's see what happens. Can we get a sound first? Let's press A. Oh, we get a sound now, but it continues forever. Okay. So why does it continue forever? When I lift that key up, it should okay, so because the reason why it's playing is that the note is still going, even though we've lifted the key and removed the key from our oscillator array. That note is still going, so we need to switch the note off. Okay, well, we can do that. We want a note off property. So let's create a new a boolean called note on there, and what we want to do here is say if note on, then we want to do all of this. Else we want to return 0, because returning no bytes. We requested 1,400 bytes or 44,100 bytes. If we return 0, that means that the oscillator has finished, and then there should be disconnected from the mixer. Because when we don't produce any output into the mixer, it should discard our oscillator that we've added to it. That's the theory I've got anyway. That's how I think that mixer works. Which is why we were getting silence. and why we continued to get the note after we'd lifted the key. So let's try that again. No, we can't try it again yet. We need to actually toggle note on and note off. So on key down, we want to toggle, we want to say oscillators, key val, dot note on, was true. And here we want to say equals false. Now this isn't going to be good enough when we have our envelopes, because by setting note on to false, that's going to cut the sound off immediately. We're not going to get the chance to shape the end of a note, the tail of a note, so when it kind of dies away. If it's a church organ, it kind of dies away quite a long period. If it's a bell, it rings on for quite a while. If it's a piano with the dampening pedal pressed, it will stop immediately with staccato. So we don't get that character of note by doing this, but adding sound envelopes is not something I want to try and do today. I don't think it'll be that difficult actually. We don't need this anymore, I don't believe. Let's get rid of that. We can always bring it back. Okay, synth. Start the synthesizer up. Switch it on. So now I'm going to press A and it should switch off. And it does. Okay, so let's now try and play two notes at the same time. So we'll play an A and a C sharp. We have polyphony, chaps. We've got polyphony, so let's try play. Let's play the chord of A major. Hey, we got a chord. So also this should mean that our notes are reasonably well blended together when we press two notes quickly. So let's try CE. So there's a certain point where that becomes a bit difficult, and I think the reason why we get that kind of harshness as I increase the rapidity of the two keys is because we don't have it's a sharp cut off of the note. If we have a tail to that note, so that the release happens over a fraction of a second rather than instantaneously, we should get that blending of the two notes, and that harshness should go away. AK47, many thanks for the follow. Brilliant. So what you're on 196, only 4 follows away from reaching our target. So I'm really grateful for that. So thank you so much, AK47. Okay, well let's see what we got in our upper octaves. So let's try that note, that chord of A again. And then in the upper octave of our keyboard. I don't think we want to go much higher than that, do we? That's all. That audio is visible, is audible to you all. You can all hear that. Okay, it's quite loud in my earphones, so hopefully you can hear it on the stream. Turn off. Okay. Well, I'm going to count that as a success. We've got Fuel Snowball's PR installed into the project, and now we've got T4 templates producing our view model, or part of our view model, which is really nice. That's this template here. We've managed to extend our UI a little bit to bring in this octave control. There's quite a bit more we're going to want to do with our UI though. And we're going to want to be able to control some more aspects of the sound. So when we get the envelopes, for example, we're going to individually control each of those, what's called the attack, the delay, the sustain, and the release. Those are all variables we're going to want to be able to control. And we'll have sliders. I think we'll try some vertical sliders just for a change rather than the horizontal ones. Yeah, and then I think some kind of visualization on here might be quite fun. We'll see what we can do. But I'm quite pleased that we've actually managed to do that. So yeah, we've got our main window. We've changed our synth wave provider quite a bit. Another thing we're going to need to do is better select the waveforms. So I think that's what we'll start off with next time, is selecting what waveform you're going to play your notes with. Currently, we've just kind of hard coded in here. We're playing a square wave, but we could have simple sine waves. We could have our harmonic sine waves, and we can have our sawtooth wave. And we can maybe find the maths for some other types of wave as well. This as a sawtooth wave isn't particularly nice either. There might be a better way of calculating a sawtooth wave mathematically rather than just doing this simple division. So we'll do that. We'll have wave selector. Then we'll look at shaping our notes so they blend together a bit nicely, so we don't get those clicks. It's quite clicky when you press and release. So we're going to smooth that out a bit, and then make that so we can control all those variables. So I'm quite pleased with that. Yeah, I think this class is going to have to change a little bit though. This note on or off concept here, it works for us quite nicely now. This idea of if the note is on, continue producing samples, but when it's off, immediately go to 0. We need it to decay in some controlled fashion, and a variably controlled fashion there. So I think that's what we're going to do in the next stream. Now, next stream, the schedule says Monday, but actually it's going to be Tuesday because I've got a family birthday celebration on Monday. So please put in your diaries that Codebase Alpha's next stream, contrary to expectation, will actually be on the Tuesday at 9 o'clock in the evening, UK time. And with that, I think what we'll do is we'll push our code up to GitHub. So we'll commit this with episode 35, yeah. Ancient Coder, thank you for dropping by, and thank you for your support, and hope you enjoyed the stream. So our GitHub is here if you want to download the repo and have a play, or do what FuelStable did and submit a PR. Why not? Let's commit the changes and let's push up to GitHub. So that code will be there in a very few seconds. There it goes. So it's there. So you're completely welcome to clone that repo and do what you will with it, or to fork it and produce PRs for me, and I'll consider all PRs. Yes, to have a play on Ancient Coder, I think it's a fun little thing, and I mean it's something probably people did all the time back in the day with their hobby computers and their BBC Micro, or their, in my case, my Ohio Superboard 2. But we're using kind of .NET Core 3, we're using WPF, we're using a digital sound library, and using really quite advanced concepts without kind of this idea of the signal chain and the mixer. So we've got this mixer which is mixing all our sounds together, and then we're controlling the volume afterwards. So this is like a multiple input mixer, so lots of inputs coming into it, controlling the volume afterwards. And then we can put other effects afterwards out. So we might be able to find, a delay, so we can get some echo, a compressor, so that we kind of, the compressor is not going to be that much use actually, because all our notes are going to be the same volume. So, but a compressor is what can kind of normalize volume of your notes. I'm sure there's other effects out there we can either find that are already built or build some, because all they're doing in effect is all your providers are going to do is actually have a read method, which another sample consumer is going to ask for a number of bytes, and then you're going to just simply step through the buffer. And then in this line here, the equivalent in your effect reader is just going to change what this line is. So if we go, for example, if we just take a quick look at this, the volume sample provider, I'm sure all it's going to do is multiply your buffer. They say that this is the volume control. It's got virtually nothing in it. It's simply going to multiply your buffer sample by a volume, and the volume is between 0 and 1 as a double. So that's all it's doing. So it's really quite simple. So a few stable, you're gonna go. You've got a fast Fourier transform display PR cooking. That's fantastic. It'd be wonderful. I'd love to have a nice spectrum analyzer as a nice visual. I'm sure that's really going to be with WPF. We can have, I don't know what, there's polylines and things like that, can't we, to display like a graph. And I think that would be quite a cool thing to have on our UI as we're playing. We can see all the frequencies which are contributing to our signal. It's completely useless in many ways, but the other thing we could try and do maybe is a graphic equalizer. So we could, I'm not sure how we do that yet, but we could, because you've got 16 frequencies, we could have like, I don't know, we've got 12 different frequencies, haven't we? We could perhaps have some kind of graphical equalizer where we could start to shape the output. So it could get quite interesting, and we could take it, as far as we want, as far as interest takes us, really. Okay, so we're all pushed up to GitHub. Let's just do some more admin. This video will be on YouTube tomorrow. The first episode of this new project, which is episode 34, is already up on YouTube. Here's my YouTube channel. Please do go and visit. Please subscribe, it really helps me out. It's free to subscribe to my YouTube channel, and it really does help to start build up the number of subscribers on there. In terms of discussions off stream, I have a Discord. This is your personal invite to my Discord, so please do click on that link and join me. We can talk about all kinds of things, development related, career related, or space related. Just to release it on the space thing. These are upcoming SpaceX rocket launches, and there's one coming up in a few days' time. That's not working again, is it? I think I've killed my bot. Off. And the bot's supposed to be running. Oh, I didn't. I misspelt it. That's why. This is me all over. So launches. So here's rocket launches from SpaceX, and there's a Falcon 9. Launching in a few days' time, and then the wonderful Falcon Heavy, which is the most spectacular rocket in the world, which will be going hopefully on June 23rd. So do keep an eye out for that if you're interested in rockets and space. Okay, I'm going to now find someone to raid. So we should hopefully find somebody. Let's close this down. Let's go to Twitch. Anyone on at the moment? Oh, we've got Visual Studio, we've got
more ways of getting stronger.
Sorry about that.
Past that, 6 slotted mark. Plus you get.
Let's go over here. So I think we're going to raid Code Rush as he's currently on, and I noticed that Dev Chatter isn't streaming currently. So let's. Oh, we got Nick Larson on. No, let's go to Code Rush. It's been pretty traditional. We raid him about this time. So thank you very much for joining me on this pop-up stream. It's been really interesting to work on this, and I'm really kind of pleased with that we got our first PR for the channel. So thank you very much to Fuel Sample for that, and fantastic you're working on another one. So brilliant. So let's raid Mark Miller at Code Rush and go and see what wizardry he's up to. And I will see you next Tuesday. Remember, Tuesday for the next episode of Codebase Alpha, where we'll continue with this project. So take care everyone, and I'll see you again then.